In this lecture video, I'm going to go over how to write out chemical formula and also how to name ionic compound. So before we get into that, I would like to go over, just recall you from the previous chapter. Okay, so what are the combinations that make ionic compound? Okay, so from the previous chapter, we learned that when you combine metal, okay, so these are the metal together, including this F block as well, but majority would be in S and D block right here. This is going to be the metal part, okay? When you combine this together with the non-metal part, okay, so which is this part right here, I'm just going to NM, okay, so you are going to end up with ionic compound. When you write out the chemical formula, it's going to be this order right here. Similar to how you read the periodic table where you read from left to right, how you write out chemical formula would be the same. You are going to write out the metal first, followed by the non-metals. That's always the case. Okay, so the cation come first before the anion. So metal come first before the non-metal. Okay, so next one, since we know this already, so I'm going to go ahead. Okay, so let's take a look at what we need to know. Okay, so in the previous lecture, I already mentioned something about the ions, right, for both cation and anion and how to determine them, especially with those in the main group element. Okay, so we need to know how to determine the charges. Okay, so with these charges, it will tell us about the number of electrons that will transfer. So electron will always transfer from cation and anion, and the amount of the transferring will have to be the same. For example, if the cation give off 2 electrons, these 2 electrons will need to transfer completely to anion. Anion will have to accept those 2 electrons, for example. If it transfers 6, then it means that cation will lose 6 and anion will accept 6 of them. So they have to be the same number of electrons transfer. Okay, so in order to follow the law of conservation of matter. Okay, so next one, before we move into how to practice how to write out the chemical formula, we will need to determine the charges. Okay, so this is going to be part of chapter 4.3. Okay, so if you want to recall that. Okay, so part of chapter 4.3, we can determine charges of the element based on their location of the periodic table. Okay, so for example, if you're looking at this one right here, group 1, right? So of this group 1 right here would have positive 1 charge. Okay, so based on the location and how they can lose electron and achieving the number of valence electron as noble gases. Okay, so the noble gas contain 8. So if this group lose 1, they are going to achieve that 8 electron in their outer shells. If you're looking at group 2, it would be 2 plus, right? So we see this before. We skip the whole transition metal, and I'm going to tell you why. Okay, so later. So and how to determine that charges as well. And then we are going to skip to this group right here, right? So aluminum. Okay, so aluminum group would be 3 plus. The reason why I'm not including boron, because boron is metalloid. Okay, so which means that when they form compound, they would not form ionic compound. They are not going to give off electrons. They are going to most likely sharing their electron with other elements. So that's why the type bond would not be an ionic bond. Okay, so that's why I'm not including this. Same thing with group 4A as well. So majority of these, okay, so they are going to most likely going to form not ionic bond, but it's going to be the covalent compound here, because we have metalloid and we have metalloid right here and we have metal right here. Okay, so what I'm gonna include though is going to be part of the metal of group 4 right here. Okay, so this part I'm going to talk about these two later. Okay, so these two lead and tin. So this one I will include this later. Okay, so but you don't need to know that charges now. So I'm going to skip to group 5A. Okay, so group 5A, when this group, okay, so when this group right here react with metal, they are going to accept the electron and they are going to accept 3 in order to achieve the octet. Okay, so same thing with group 6A here. Okay, so this group is going to accept 2 more electron, have charge of -2. Group 7A would be -1. Okay, so this is the general idea of charges based on the location of the periodic table. So what I'm going to do next is that I'm going to go ahead. Okay, so look at each of these, right? So for example, magnesium is in group 2A. So therefore, if magnesium undergo chemical reaction to form ionic compound, magnesium would be 2 plus. Another one would be gallium. Gallium is in group 3A. So therefore, in this case, gallium would be 3 plus, potassium would be 1 plus, for example. Selenium in the same group as oxygen, that would be 2 minus. Chlorine group 7A, that would be 1 minus. Now the problem comes when we're looking at, for example, iron. Okay, so iron is part of the transition metal. So iron, therefore, will not be able to we will not be able to tell what charge would it be, because in nature there are several type of iron. It can be iron 2 plus or iron 3 plus. The color of iron 2 plus and 3 plus will not be the same. Okay, so in order for us to determine this, we need to look at the overall chemical formula in order for us to be able to deduce like what are their charges. Okay, so just note that you do not need to memorize the charges for transition metal. So therefore, the naming of the transition metal will be different from the main group element. Okay, so of this, I know that charges, this is what I refer as main group element. They are part of the main group element, which is block S and block P. Okay. There are two exceptions that you need to know. Those are silver and zinc. Okay, so zinc and silver are the two transition metal that will have only one single charge. Okay, so silver would always be positive 1 and zinc would always be positive 2. So these are the only two that you need to know. Okay, so everything else for the transition metal, you do not need to memorize. Okay. All right, so I'm going to refer of this as one specific charge. Okay, so these main group elements, they are going to have a specific charge, only one. Okay, so same thing with zinc and silver. Okay, so these are going to what I'm gonna record this as monoatomic ions. Okay, so this is what we call mono mean one, atomic mean atom is the one atom ion. Okay, so these are what we call monoatomic ion. If you're looking at cation, such as those that I highlight right here, these are going to be monoatomic cation, right? And then this one would be monoatomic anion. Hey, Ami, how come that you have H right here as red? So just note that when you're looking at hydrogen compared to the metal part are going to be the one that will lose electron, and in this case, hydrogen would be the one that would accept electron. So hydrogen most likely going to be a negative charge in this case. Okay, so because when you're looking at ionic compound, you combine between metal and non-metal, right? So if you combine metal and non-metal, in this case, hydrogen would most likely behave as non-metal, which is going to accept the electrons. Okay. All right, so next one, I'm going to use those idea of charges and then help us to determine the chemical formula. Okay, so in this case, I'm going to go ahead, look at the cation that is given to us. Since it doesn't tell us what it is, I'm going to give this as X. Okay, so this cation X contain 2 plus. So I'm going to go ahead, do 2 plus. Okay, and then we have anion with -3 charge. So I'm going to give this as Y. Okay, so Y is -3. So when you are write out chemical formula, so as I mentioned in class before, the charges at the end, when you combine all of them together, it need to give you 0, which means the compound need to be neutral. So these charges right here that you are going to combine, it need to come out to be 0. Okay, so the easiest way to look at this is you would need to look at the common number. Okay, so because the common number would tell us about the common number of electrons that transfer, because remember the number of electrons have to be the same, right? If you're looking at between 2 and 3, the common number would be 6, right? So that means in this case, we need X to have a total of 6 plus. Same thing with Y. We need Y to have a total of 6 minus, because it indicates that these 6 electron right here transfer to Y, right? 6 electron from X transfer to Y. Therefore, if you add the number of charges together, +6 add to -6, it would give you 0, which is exactly what we want. Okay, so we want it to be neutral. The next question is, okay, well, we need +6 from X, but each X is only 2 plus. So how many X do we need then? The answer would be 3, right? Because 3 times 2 equal to +6. Same thing with Y as well. In order for us to achieve -6, we need 2 of Y. So therefore, in this case, because we know how many we need for each of those, then when you write out chemical formula, each of those that you need going to become our subscript. So therefore, the correct chemical formula would be X subscript 3 and Y subscript 2. Okay. If you calculate for their charges, you will see that we have now 3 times plus 2 add to 2 times negative 6. Oh, sorry, negative 3, right? Because each of charges of Y equal to negative 3, the answer will come out to be equal to 0, which indicates that this compound is neutral. Okay, so that's how we write our chemical formula of any compound. Now let's take a look at the actual element. Okay, so we are going to take a look at the actual element. So in this case, for example, sodium and oxygen. If you look at the periodic table, sodium is Na, oxygen is O. So what I'm going to do is I'm going to, based on the location of the periodic table as well, sodium is in group 1A, so therefore the charge of this would be +1. Oxygen is in group 6A, so it would be -2. So you probably notice that if I want to find common number between 1 and 2, the common would be 2. So therefore, in this case, in order for me to add the charges to equal to 0, right, I need -2 and +2. So therefore, what indicate to me is that I need 2 of sodium in order to balance the charge of the oxygen. So therefore, in this case, the chemical formula of this would be Na subscript 2 and O. Okay, so that's pretty much what it is. Okay, so up until this point, I would like you to go ahead, pause the video, okay, so, and look for the chemical symbol for each of those elements, and then look at their charges and come up with the correct chemical formula of this, okay, so when you are done, then you can check your work against the video, okay, so I'm gonna go ahead, let you pause it and then resume it when you are ready. All right, so let's take a look at next. Okay, so calcium. Okay, so calcium in group 2A, so that would be 2 plus. Nitrogen is in group 5A, that would be 3 minus. So together, common number of this would be 6. So therefore, I would need 3 of calcium per 2 of nitrogen in order for me to get +6 and -6 to add to 0, right? So therefore, the chemical formula would be calcium subscript 3, nitrogen subscript 2. Okay. Next one, magnesium. Okay, so same thing, magnesium is in group 2A, so 2 plus. Bromine is in group 7A, so that's 1 minus. The common number of this would be 2, so we need +2, we need -2, so I need 2 of bromine in order to add all the charges to be equal to 0. So therefore, the correct chemical formula of this would be magnesium and then 2 of the bromine. Okay. Next one, aluminum and sulfur. Aluminum is in group 3A, so that would be aluminum 3 plus. Sulfur is the same group as oxygen, so that would be 2 minus. Again, common number of these would be 6. So therefore, we are going to get 2 of aluminum per 3 of sulfur. So that way we can have +6 and -6 to add them equal to 0. Okay, so therefore the chemical formula would be aluminum subscript 2, S subscript 3. All right, next one, we are going to get into a little bit more challenging. Okay, so what we are going to do next is I'm going to incorporate the previous one that we did before. This is what we call monoatomic ion. So now we're going to get into not just the monoatomic ion. Okay, so these are monoatomic ion. These are example of monoatomic ions. I'm going to also incorporate what we call polyatomic ion as well. Okay, so what are the polyatomic ion? Poly mean many, is the many atom ions, which means it's the ion that contain many atoms. Example of this would be like this one, right? So because contain many atoms, okay, so example would be this one, that one, that one, that one, and that one. These are what we call polyatomic ions. You will be given the list of polyatomic ion on the exam for this course, case 121. However, after this class, you are going to use them often enough that you are going to be able to recognize them when we get into Chem 122. So hopefully by the end of this term, you should be able to recognize all of these polyatomic ion. Okay. Oh, sorry. So let me actually show you what are the polyatomic ions. Okay, so these are example of polyatomic ions. I'm going to go over the name later, but just note that the name imply, right, is the ion that contain many atoms. Okay, so these are the ion that contain many atoms. So let's take a look at, now let's take a look at how to write out the chemical formula. So I'm going to go ahead, look at a couple of these. Okay, so I'm going to let you pause the video and then do it yourself. So I'm going to go ahead, do the first one. Remember, when we write out the chemical formula, we want to write out metal first, followed by non-metal. So it's clearly that these are metal. So that means in this case, we're going to write this first. These are metal. Metal followed by non-metal. Okay. The problem comes when you see an anion that doesn't have metal, okay, element, such as ammonium. Ammonium is the only cation that doesn't have any metal, or is the only cation that contains all the non-metal. So nitrogen and hydrogen are non-metal, but the overall, this is cation, making the compound that contain ammonium to be classified as ionic compound, because ionic, literally the name come from ions, but it's a compound that contain ion. What are they? It's the cation combined with the anion. This is the only one exception that you need to know, that ammonium containing ion, even though it's all going to be non-metal, this is classified as ionic compound because ammonium is the cation. Okay. So when you see this, the easiest way to recognize this would be you are going to always write cation first before anion. Okay, so that means including both metal and also ammonium as well. So I'm going to go ahead. Okay, so start with the first one. We see that ammonium is +1, bromine is already -1, so it's already 1 to 1, right? So the ratio is already have the common number. So therefore, you're gonna write as NH4, okay, and then Br. That's it. Okay, because the charges already balanced. Now, what about barium and bromine? So same thing here. We have 2 plus, we have 1 minus. So therefore, in this case, you are going to need one of barium, okay, for every 2 bromine, right? Because you need 2 negative in order to balance the 2 positive. What about aluminum and bromine? Okay, so this is 3 plus, that's 1 minus. So therefore, in this case, for every 1 aluminum, we will need 3 bromine. Same thing with manganese as well. Every 1 manganese, we will need 4 bromine in order for the charges balance it out to equal to 0. Okay. So next one, ammonium and sulfur. You probably noticed that for ammonium and sulfur, you will see that, oops, so let me actually delete this real quick. You will notice that in this case, for every ammonium, right? Ammonium is +1, sulfur is -2, so you need 2 of ammonium in order to be the same, to have the same, what do you call it, electron transfer as a sulfur 2 minus. So if I do this 1 to 1, you probably recognize that it's not going to balance the charge yet because ammonium is +1. So we need 2 ammonium. How do I represent ammonium with the 2 plus? How do I represent this then, right? Like if we need 2 of them, you will need to use parentheses. Okay, so parentheses subscript 2 indicate that you need that whole group, 2 of them, which is exactly what we want because this +1 is +1 for the whole group. Does that make sense? So we need the whole of them to like, like for one of that. So let's take a look at a little bit more complicated one. Okay, so what about if I combine ammonium with phosphate, which is PO4 3 minus here? What should I do? You probably notice that phosphate contains 3 minus, ammonium is 1 plus. So therefore, I need 3 of the ammonium. Okay, so that way you have 3 plus total to balance the charge of phosphate 3 minus. So in order to do this, because I need because I need 3 of ammonium, so I'm gonna go ahead, write out ammonium NH4 because we need 3 of them. So we do parentheses subscript 3 and then followed by phosphate PO4. Okay, so PO4 come as a whole group. Okay, so if you're looking at charges, it would make sense right here. Each ammonium is +1, but we have 3 of them, right? You add this to -3, which is of phosphate. Therefore, the total will come out to be 0. Okay, so that's why this chemical formula is already neutral. Okay, so that would be it. So I'm going to show you another one. Okay, so this one look complex, but it's actually pretty simple. I'm going to combine ammonium together with acetate ion. This is called acetate ion. So again, cation come first. So all we have to do is going to be ammonium subscript 4, followed by an ion, which is the acetate. You probably notice that the acetate, the overall charge is -1. Ammonium is +1. So they already are in 1-to-1. So all you have to do is it's going to be CH3CO2. You just write the whole group without any parentheses. If you need more than one of polyatomic ions, you use parentheses. If you just need one of the polyatomic ion, you don't need parentheses. Okay, so that's the key point of this. I'm going to show you a couple more before I let you do it yourself. Okay, so next one, I want to go ahead, look at aluminum and phosphate. Okay, so aluminum is 3+, phosphate is 3-. So in this case, it's just going to be 1-to-1, right? Because 1 aluminum would be per 1 phosphate. So as I mentioned before, if you need only one polyatomic ion, then you don't need parentheses. So therefore, aluminum phosphate, it's just going to be that. Okay, so if you want to check the charges, okay, so it would be 3+ add to 3-. This is equal to 0. Exactly what we want. Okay. All right, let's take a look at next one. Let's see what else can be complicated right here. Let's do manganese and phosphate. Okay, so manganese is 4+, phosphate is 3-. So in order for me to balance the charge for this, I'm going to find out common number. Common number between 4 and 3 is 12. So that means what I need is I need +12 from manganese, and I need -12 from phosphate. Okay, so in order for me to get a -12 from manganese, I need 3 of the manganese. So therefore, in this case, my manganese would be Mn subscript 3. And then my phosphate, because each phosphate is -3, I need -12. So I need 4 of them, right? 3 times 4 equal to 12. So therefore, in this case, you are going to use parentheses and do subscript 4. Okay, so if you are not sure, you can go ahead calculate the charge again. So I'm going to go ahead calculate the charges again. Okay, so we have 3 manganese, each +4. We're going to add this to, we have 4 phosphate, each is -3. So therefore, total will come out to be 0. So exactly what I want, right? Because we want a neutral compound. Okay. So what I'm going to let you do is that I'm going to go ahead, let you complete the rest of these. Okay, so pause the video now. And then in your lecture manual, can you please go ahead, write out all of those answers? Okay, so it's okay to get it wrong because this is the practice time. Okay, so get it wrong, fine. Okay, so let's go ahead, complete the remaining. When you are done, you can check the video. Okay, so resume the video again to check your answer. So go ahead, pause the video, please. All right, so if you are done with your work, okay, so go ahead, check your work against my solution here. So these are the correct solution. Okay, so if there is anything not matching and if it's still confusing to you, please come talk to me. Okay, so please talk to me after class. All right, next part, we're gonna get into the naming now. Okay, so before I get into the naming, I would like to go ahead talk about polyatomic ions real quick. Okay, so you probably notice here when we're looking at polyatomic ion, okay, so you probably notice that polyatomic ion has a certain name. And the most common one that you can recognize whether these ions are polyatomic ions or not is going to looking at their name. Okay, so if the name ending with 8 or 8, they are going to be the name of polyatomic ions. Okay, so for example, nitrate, right? So ending with 8. Okay, so right here, ending with 8, nitrate. Nitrite ending with 8. So perchlorate, chlorate, chloride, hypochlorite. You probably notice that all of these are ending with either 8 or 8, all of them. So that's how you are going to recognize them. Okay, so every time when it's ending with 8 or 8, you know that these ions going to have more than one single ion. These ions going to come with oxygen. Okay, so that's all you have to know. If it ending with H or I, they're always going to come with oxygen. Okay, which is what we call polyatomic ion. When we're looking at polyatomic ion, one that doesn't ending with ate or ite is going to be ammonium. Okay, so ammonium hydroxide and cyanide. Everything else will ending with ate or ite. Okay, so another thing I want to point out is ammonium. Ammonium is going to be the only polyatomic cation that you will see. Okay, so you probably noticed that everything else are anion. So all of these are anion. The only thing that is cation would be ammonium, which make ammonium containing compound to classify as ionic because ammonium is an ion. This is ammonium ion. Okay, so that means in this case, if you see something like this, NH4Cl, even though they all contain non-metals, this is going to classify as ionic compound. It's just because it is contain ammonium ion. So this comes from positive ammonium ion and chloride negative ion. That's why they classify as ionic compound. Okay. The two that do not end with ate that are anions would be hydroxide and cyanide. These are something that you would just need to know. Okay, so whenever that we're looking at when we talk about hydroxide, just know that it's going to be this OH. If it's cyanide, it's going to be the CN. Okay, so those are the two that you need to just memorize. Okay, so with that being said, I'm going to go over the name and all of this later. One thing that you can also recognize is between the difference between ate and ite. Okay, so ate would have more oxygen than ite. Okay, and then if you have any more oxygen than ate, then the name would contain the word per. And if the oxygen in the compound have less than ite, then you are going to add the word hypo. For example, chlorate, right? So anything that have more than 3 oxygen would be perchlorate. And if chloride is have one less oxygen than chlorate, then anything that is less than ite right here, you're gonna see that there's the word hypo adding to it. Okay. All right, so let's take a look at the naming. Okay, so the systematic naming of any compound, I'm going to refer this as IUPAC system. The reason why I said IUPAC system because it's the systematic naming. Okay, so there are other name as well, such as like me, right? So like for example, my official name would be like Amidala, but my nickname would be Ami. So same thing here. The nickname of any compound depend on the common name. So for example, the IUPAC name of this would be sodium chloride, but the common name of this would be like table salt, for example, right? So you might see that some of the ionic compound will have several names. It's just because of one might be the systematic naming and the other might be just the common name that people know about. Okay. All right, so what I'm going to teach you though is the systematic naming, which is what we call IUPAC name. Okay. So there are 4 different types that you will need to just know. The first one is when you're looking at ionic compound that contain 2 like element. Okay, so 2 type of element. And this type of element, since we have only 2 of them, we call them binary, bi mean 2. Example of this would be such as I just give you before, sodium chloride, right? So you'll see that there are 2 elements. So that's why we call binary. Or like, let's say the one that you did in lab, right? So iron oxide, for example. Okay, so these are what we refer as binary compound. The difference between 1 and 2 naming system is that 1, you are looking at one single charges. Remember, those are going to be part of the main group element. Okay. Second one, you are looking at the multiple charges. Those are going to be the transition metal, except silver and zinc. Okay, so that's gonna fall into silver and zinc, going to fall into the first system. Okay, so I'm gonna go over how can we do that. Okay, so in just a few minutes here, so I just want to give you like a broad picture first. Third one is the non-binary, which means you're gonna have many of them. Okay, so it can have multiple elements. Example of this going to be those that contain polyatomic ion, such as, okay, so in this case, example of this would be something like this, ammonium, right? So NH4Cl, for example, is contain many elements. Okay, so we're gonna talk about the name of this as well. And the last one, This is going to include all of these four, but we're gonna add water to it. Okay, so it's just a ionic compound with water. Okay, so we're gonna look at how can we name that. Okay, so this is, if you think about this, it would be more like these are dry ionic compound. This is more like wet ionic compound because you actually add water into the sample of those ionic compound. That's pretty much what it is. All right, so let's take a look at one specific charge first. Okay, so again, to just remind you, it's going to be this group 1A and 2A and 3A here, including zinc and silver. Okay, so silver would be +1, zinc would be +2. Okay, so how do I name it? Okay, so, oh, actually, and then the one that have multiple charges would be the rest of that metals. Okay. Okay, so now let's take a look at how can we name them. Okay, so for the binary system, it's pretty much the same. You are going to name metal first, followed by the non-metals. Okay, and then you are going to change the name of the non-metal to end with "ide." So I'm gonna go back to here real quick. So I'm going to start with the one specific chart. For example, these are the name of metals. So you're gonna read as is. So for example, lithium, you're gonna read as lithium. Aluminum, you're gonna read as aluminum. Silver, you're gonna read as silver. And then you're gonna follow by the name of the non-metals, but we're gonna change this non-metal to end with "I." For example, hydride, carbide, nitride, phosphide, oxide, sulfide, selenide, fluoride, chloride, bromide, iodide. Okay, so that's how you do it. You probably notice that you're not gonna observe this much, the one with the noble gases, because noble gases will not react. So oftentimes it's gonna be a small amount of what do you call, like anion sample right here that are monoatomic ion. Okay, so which means if you just go through this, it's pretty easy to memorize, right? Like hydrogen, you change to hydride and so on. Okay, so now let's go back to here. So let's take a look at example. Okay, so for example, calcium is main group element is contain one specific charge, which is +2. So therefore, in this case, I'm just gonna name as it is calcium. Chlorine, we're going to change this to chloride. So therefore, the name would be calcium chloride. This is main group element again. This is binary ionic compound because it contains two elements. Okay, so two type of element. So therefore, the name would be magnesium. And then nitrogen changed to nitride. Okay. Now, the problem comes when you deal with transition metal other than silver and zinc. Okay, so I'm going to go ahead, look at this. When you are dealing with transition metal, okay, so including lactinide, actinide as well, you will see that in this case, they can have various charges. Okay, so again, except silver and zinc. And I would like to include the post metal as well, which are, even though these are in the main group element, but tin and lead, they can have various charges as well. So don't forget to include tin and lead. Okay. So what do we do if they have multiple charges then? Well, if you have multiple charges, then you need to be able to specify what are we talking about? Are we talking about iron 2 plus or are we talking about iron 3 plus? Because in nature, these two are going to have different chemical properties and also different reactivity as well. So we need to be able to specify which one it is, right? So in order to do this, we are going to specify the charge of the metal after the metal. Okay, so for the first one, we do not need to include the charges of all of this because we know that charges based on their location on the periodic table. But the one that we don't know their charges, we need to specify their charges by using Roman numerals. Okay, so these are the Roman numerals. For example, if iron 2 plus, we are going to specify with the 2 here. If it's 3 plus, then we specify with 3 plus. Okay, and then you are going to follow by the name of non-metal, similar fashion that we did before with the first system. Example of this would be Fe2O3. Now you might ask me, okay, Ami, I understand the name of metal would be the same, which is iron, and the oxygen would be oxide. But how do I figure this out then, Ami, like this chart of metal right here? The answer is that you will need to refer to our previous lecture, right? So we talk about how molecules or compound, they need to be neutral. So that means we need to go ahead, set up these compound in such a way that you add them up together equal to 0, which means that the charge of the oxygen, since we have 3 of them, and based on what we know about oxygen, which is the main group element, we know that the charge of oxygen is -2. So therefore, in this case, together with iron, we can actually deduce the charge of the iron. Does that make sense? So in this case, I don't know what is the charge of iron, but I know for sure that iron contains 2 of them. So every 2 iron add to 3 of oxygen, it need to equal to 0. If you do algebra right here, right, so you're going to get 2 iron minus 6 equal to 0. If you do algebra, you are going to get iron to come out to be +3. Based on this calculation, I know now that my iron is 3 plus. So therefore, the name would be iron, parenthesis, Roman numeral 3, followed by oxygen changed to oxide. Okay, so that's how you do it. Now let's take a look at another example. So same thing here, titanium is part of the transition metal that we don't know their specific charge. So therefore, we need to deduce to get the charge of titanium. So I'm going to do the same thing. Each oxygen is -2. We have 2 of oxygen. We don't know what is titanium. We're going to set this equal to 0 because everything will need to add to 0. So together, we're going to get titanium come out to be +4. Okay, so therefore, the name of this would be titanium, parenthesis 4 Roman numeral, followed by oxygen changed to oxide, followed by oxide. Okay. All right, next one. Okay, so next one is going to be the name that contain polyatomic ions. Okay, so this is might be the most simplest one because as long as you know the name of the polyatomic ion, the name would be as is. You never change this name. Their name will stay the same. Okay, so these ions, their name will stay the same. So for example, the first one, right? So you recognize ammonium. So the name would be just ammonium. This NO3 is nitrate. So the name would be ammonium nitrate, for example. Sodium, it would be sodium nitrate. Now, the problem comes when you have transition metal such as this. Cadmium, the name would be the same, except that because we need to specify Roman numeral. Hey, Ami, how come that I don't have to do with sodium? Again, as I mentioned before, if you know the specific charge, you do not need to use Roman numeral. And we do know the charge of sodium, which is +1 because located in, group 1. What about ammonium then? Why don't I specify the charge of ammonium? Same thing, because ammonium always going to be +1, so that's why I don't need to use Roman numeral. This is not the case. Cadmium can have various charges, so therefore I need to specify this. So the name of this would be cadmium. Cadmium what? Same thing, the analysis would be the same as what we did before. If you want to know these charges, and we need to find out something else first, based on the list of polyatomic ion, each of nitrate is -1. We need to add this to cadmium, and these two add together need to equal to 0. Hey, what about the subscript? Do we need to multiply by 3? The answer is no. Remember nitrates, NO subscript 3, this whole group come as -1. So therefore, you do not need to multiply by 3. Okay, so it's the whole group that is -1. So with this being said right here, we see that cadmium come out to be +1. Okay, so therefore our cadmium would be 1, and then followed by nitrate, for example. Okay. All right, the last one is the hydrate ionic compound. Hydrate ionic compound, you are going to name everything the same way that we did before in 1, 2, and 3. Okay, so the fourth one, the only thing we need to add is the water. Okay, so the name of the water. So the name of ionic compound would be as is. The water though, water is H2O. Okay, water is not an ionic compound. Water is molecular compound. When you name molecular compound, we need to specify the number of how many of them by using the prefix. The prefix will tell you about the number of water. And the name of the water, we're gonna use the word hydrate. Okay, so what do I mean by that? Okay, so let's take a look at example. Okay, so for example, this is example of it. Okay, so This is an example of ionic compound that contain water, which is what we call hydrate ionic compound. It's the wet ionic compound. These are what we call anhydrous. If there is no water come with the chemical formula, we call anhydrous, which means they are super dry. They are dry, right? There's no water molecule. So how do we name this? Okay, so same thing. We are going to use the system that we learned before in terms of ionic compound. Barium is the main group element. So I know the charge of barium. So therefore, I do not need to specify the charge of barium. So it's going to be just barium. Okay. N. If it's only single element for an anion, if it doesn't come with the oxygen, the ending would end with "ide." So that's how you differentiate them. So in this case, you are going to name this barium nitride. Okay, so note the ending. Okay, so if it's ending with "ide," it's only one single element. Okay. If it's ending with 8, okay, so these are ending with 8, right? So you're gonna see that it's gonna come with oxygen. Okay. Now, what about this 5 water then? 5 water, you are going to specify the number of water by using prefix. Prefix for 5 is penta. So therefore the name would be penta. And then water gonna be hydrate. So it's gonna ending with hydrate. So therefore the name of this would be barium nitride pentahydrate. Okay. All right, so this is pretty much everything now. So based on this, you are welcome to make your own flow chart. Okay, so I'm going to go ahead, let you pause the video now. Okay, so go ahead, let's pause the video and complete example. Okay, so on the lecture manual, page 85 to 86. When you are done, resume the video again so that way I can go over all of this answer with you. All right, let's take a look at the first example. Okay, so go ahead, check your work. Okay, so this one, you probably recognize of these are going to be the ions, right, that are going to be the charges that known. Okay, so potassium, strontium, calcium, they are in the main group element. We know their charges. So therefore, when we name them, we don't use Roman numeral. So K is potassium, the name would be potassium. And I, this is if you have only one anion, okay, so or the non-metal, okay, so non-metal. Again, name will changing ending to I. However, if you see the non-metal that come with oxygen, okay, so the name of this will ending with either 8 or 8. Okay, so just the difference is that. Okay, so if it's just one single one, it would be ending with I. The only ide that is not a single element would be hydroxide and cyanide. Those are the only two that you just need to know that the ending I is not the single element. Okay. All right, so what about second one? Okay, so strontium is SR, chloride is the Cl. In order for me to get the correct chemical formula, I need to balance the charge. Strontium is 2 plus, chlorine is 1 minus, so therefore I need 2 chlorine per 1 strontium, so therefore it's going to be Sr and then Cl subscript 2. Okay. C, the name would be calcium nitride. Again, this is not nitrate or nitrite because nitrogen is only one single nitrogen. Okay, so I'm going to compare the different again. If nitrogen come as single, okay, so if nitrogen come as single like this, the ions charges would be based on the location predictable. Okay, this is gonna be ending with "ide." Okay, and if you see N come with O, okay, so this is gonna ending with a nitrate. And then if you have reduced oxygen, it would ending with ite, which is nitrite. Okay, so those are the difference between the two. Okay, so nitri, I, one element, 8 or ite would be 2 element. Okay. All right, next one. Okay, so same thing with next one. So you probably recognize that all of these are part of elements that can contain various charges. So that's why we have to use Roman numeral. Okay. So let's take a look at the first one. The first one is giving you name. You need to convert to chemical formula. So same thing that we did before. Tin is SN. Oxide come from oxygen, so O. So you probably notice that these two, These two doesn't tell us about subscript, but it tells us about the charge. Charge of what? Always charge of the metal. So it tells us the tin is 2 plus. Oxygen, based on the location of the periodic table, it would get 2 minus. So this is already 1-to-1, right? So every 2 electron going from tin will go directly to oxygen. So therefore, the chemical formula of this would be just SNO. Next one, mercury. Okay, so in this case, mercury is the transition metal, so therefore we need to deduce the charge. Okay, so I don't know what is the charge of mercury, but we know the charge of bromine. So each bromine is -1. Together, we need to add this equal to 0. So therefore, we'll see that mercury in this case is +2. So therefore, in the name, it would be mercury 2, and then ending with I for bromine. Okay, so bromide, because just one single element for this anion. Okay. Oops, sorry. All right, next one, chromium 3 nitride. So same thing again here. In order for us to write the correct chemical formula, you're going to do chromium 3 refers to the charge of this, so it would be chromium 3 plus. Nitride is the N, ending with I, so it's just going to be the N. Okay, so it will not come with the oxygen, and then would be 3 minus. So again, it's 1-to-1 again. Next one. Okay, so lead. Okay, so with lead, you're gonna determine the charge of this again. So we don't know what is the charge of lead, but we know that sulfur is -2 because on the same group as oxygen. Add this together, it need to equal to 0. So therefore, lead come out to be +4. So the name would be lead, parenthesis 4, and then sulfide. Again, we're ending with I because this is just one sulfur. Okay. Now this one, we are going to mix all of those together with ionic compound. Okay, so in this case, we just need to know what is the chemical formula of ionic compound. So we know that this is, so calcium would be Ca, and it's 2 plus. So look up the list of polyatomic ion. Permanganate is MnO4 with 1 minus. So therefore, based on this, I need 2 of permanganate to 1 of the calcium. So therefore, the chemical formula would come out to be, so this is, let me show you permanganate real quick. So permanganate is this one right here. Okay. So so therefore in this case, you are going to get Ca parentheses and then 2 of the manganese. Okay, so next one. Okay, so iron is part of transition metal. So therefore in this case, we need to find out the charge of iron. So if you look at, this is the polyatomic ion. Okay, so this is the polyatomic ion. So how do I recognize that, Army? Remember, like this is metal, so therefore this is the group of non-metal. So when it's come as a whole group, that is the polyatomic ion. This polyatomic ion is the bromate. Each bromate is -1. Okay, so this whole thing is BrO3, come with -1. This whole thing has a -1 charge. How many do we have? Oh, according to parentheses, we have 3 of them. Okay, so therefore, we have 3 of -1. We're going to add this to iron that is also need to equal to 0. Therefore, the charge of iron would be +3. So therefore, the name of this would be iron 3 bromate. So again, so here's the bromate. So that's the bromate right there. Okay, so therefore, the name would be iron 3 bromate. Next one, potassium hypoiodide. So potassium is K and is not part of the transition metal. So therefore, we don't need to use any Roman numeral here, right? And then hypoiodide, as I mentioned before, is the IO negative, right? So in this case, is 1-to-1 with the calcium, with the potassium. So that's why the chemical formula as is here. One thing I forgot to mention is, note that because this comes as a whole group, you probably recognize that the name will not ending with "ide." is gonna ending with either 8 or 8. So that's why you need to look up the list of polyatomic ion. Okay, so and when you're looking at BrO3, this is the bromate. Okay. All right, next one, barium dihydrogen phosphate. So if you're looking at dihydrogen phosphate, you probably notice that it's this whole thing right here. Okay, so what I'm going to do is I'm going to go ahead. Okay, so I already have the answer here, but I'm just going to go ahead walk you through this. Okay, so barium is 2 plus. Okay, dihydrogen, so H2PO4, 1 minus. Because this whole group contain 1 minus, I need 2 of this. So that's why you have subscript 2 in the chemical formula. Okay. Last one. This is still polyatomic ions, ammonium. This is carbonate. So together we have cation and anion. This is ionic compound. Okay. So the name of those ionic compound that contain polyatomic ion would be as is. So it would be ammonium, right? And then carbonate. Okay. All right, now let's get into the hydrate ionic compound. Okay, so same thing. I'm gonna go over the ionic compound. Okay, so lithium, so it would be Li. This is main group element, so +1. Nitrite. Okay, so ending with ite. So this is when you need to look up the list of polyatomic ion. Nitrite is NO2 minus. Therefore, the chemical formula of this would be just 1-to-1. It would be lithium, NO2. And next one, mono. Mono mean 1. So you are going to use the dot in the middle because water doesn't actually bond to lithium nitrate. It just surround that structure. Okay, so it's kind of wetted. So we have 1 water. So whenever it's 1, you can omit that 1. Okay, so we just do H2O. Hydrate mean water, so it will be H2O. Next one, CO. This is cobalt. Okay, so cobalt is part of polyatomic ion, so it's a CO. So I need to find out the charges in order for me to know what would be the Roman numeral. So I'm going to go ahead, look at this. Okay, so this is PO4. This is part of the polyatomic ion phosphate. So PO4 contains 3 minus. That will not change. How many do we have? 2 of them. So we have 2 of this. So that means if I'm looking at the charges would be 2 times -3 add to cobalt. How many cobalt do we have? 3 of them. So I'm going to use 3 in front of cobalt. Add this together, it needs to equal to 0. Why don't I need to worry about water on me? Because water is already neutral. Okay, so what I'm worried is just the charges within the ionic compound. So 3 cobalt minus 6 equal to 0. So that means 3 cobalt equal to +6. So that means each cobalt would be, divide both sides by 3. So that means each cobalt would be +2. So therefore, the name of this would be, okay, so let me actually erase off this real quick. The name of this would be cobalt 2 phosphate. Okay, so again, 2 come from the charge of cobalt. Okay, so cobalt 2 phosphate. Followed by, okay, so 8 is octa, would be octa, and then hydrate for water. All right, that's it for this video. So practice is the key for success. The more you practice, you will get a hang of the systematic naming.